Hi, I'm CeCe,
I'm Josh.
I'm Joe.
and this is our AC circuits videos for EET.
In Multisim right now. I'm putting a voltage source. Then I'm going to be grabbing resistors. And the resistors we're going to be using are 1.5 kilo ohm and 4.7 kilo ohm. And I'm interconnecting the components. I'm now attaching the ground to the circuit. Now I'm adding a oscilloscope. And I'm going to change the ground part of the circuit to black. And now I'm going to add 2 voltmeters into the circuit. And these are going to be the vertical voltmeters. And now I'm going to double click into each voltmeter and change the mode to AC. Okay, now we're going to update the AC power source to 3.535 volts RMS. And the frequency is going to be updated to 1000 hertz. And now we're going to run the simulation. Okay, and that's the completion of the circuit. Okay, the next step that we're going to be doing is connecting the cables and then setting the proper frequency and voltage values on the digital multimeter and frequency counter. make sure that the oscilloscope probe is set to X1 on here also, which it is. Okay, the wires are connected. Next thing we do, we're going to update the frequency on the frequency counter to 1,000 hertz. Okay. Next step we're going to do is we're going to set this to AC voltage. And we're going to change that to, change the range so we can get something a little bit more finer. And we're going to need to match that to 3.535 volts. And we're going to use the amplitude knob. On the frequency counter to get down there. Okay, as soon as okay, the next thing we're going to do is measure the voltage peak to peak within our multi-sim circuit. So I'm going to count the number of blocks across, and then we're going to times that by 5 volts. So we're going to do 2 times 5 volts right here, and that's going to give us a solution of 10 volts, which is the voltage we use for our circuit. We're going to be measuring the voltage RMS on Multisim right now. So I'm going to take our voltage of 10 volts over 2, which gives us a value of 5, and then we're going to multiply that by 0.707. which gives us a voltage RMS value of 3.535. Okay, we're next going to be measuring the period of the sine wave. I'm going to count how many blocks across, and we're going to multiply that by 500 microseconds. So we got 2 blocks across times 500 microseconds. And it gives us a value of 1 millisecond. Okay, the next thing we're going to be measuring is the frequency. And the formula for that is going to be 1 over 1 millisecond. So it's going to be 1 over 1 times 10 to the negative 3rd power. And that gives us a frequency of 1,000 hertz, which is displayed here on the function generator. Okay, we're going to be measuring voltage peak to peak, new school method in Multisim. And this is the voltage peak to peak, new school. Okay, the next value we're going to be reading is voltage RMS. And we're going to look at the voltage AC source in our Multisim. And it's 3.535 volts AC. Okay, the next value we're going to find is the period of the sine wave. And we're going to measure from the top of this wave to this wave. And that gives us a value of 1 millisecond. Okay, the final measurement from Multisim is the frequency. And how we calculate that is 1 over 1 times 10 to the negative 3rd power. And that gives us a value of 1,000 hertz, as seen here on the voltage source.
All right, the first thing we're going to measure is the voltage peak to peak for the resistor 2. It's on channel B, or channel 2. Old school method, we count the squares. You have 1, 2, 3, 4.9, and then you times that by the 500 millivolts. So you got 4.9 times 500 EE to the negative 3, which gives us the 2.45 volts peak to peak. All right, now we're going to find our RMS for channel 2, or the resistor 2. You take our voltage peak to peak, which is 2.45, and you divide that by 2, which gives us 1.225, and you times that by the 0.707, and it gives us our 0.866. And if you look right here, we have 0.85. So we're going to do the period, which is going to be from the start of the sound wave to the end of the first sound wave. And we're going to count the squares. We got 1, 2, 3, 4, 5. So we got our 5 times 200 microseconds. So 5 times 200 EE to the negative 6. And that gives us 1 microsecond. All right, next we're going to find our frequency, the old school method. We take its frequency equals 1 over time. So we're going to take 1 divided by our time, which was 1 millisecond. So 1 EE to the negative 3. And it gives us 1,000 hertz for our frequency, which is here on the screen. All right, we're going to do our peak to peak new school method. Let's set this at the top, first sine wave, and at the bottom of the sine wave, and it shows right here, it's 2.4 volts. So now we're going to do the RMS with the new school method, which is already on our AC circuit, which is right here. 3.535 the RMS.
Yep.
All right, next we're going to do the time and the frequency. So we're going to take this one here and set it to the top. Next top, we have our time, which is 1,000 milliseconds. And then to find our frequency, its frequency equals 1 over time. So we do, again, our 1 divided by 1 EE to the negative 3, which gives us 1,000 hertz. And again, there it is, 1,000 hertz.
So now what we're going to do is we're going to be measuring peak to peak. What we're going to be doing now is measuring peak to peak old school. So what I'm going to do is I'm going to count my divisions. 1, 2, 3, 4, 5, and I see about 5.2. So now to calculate that, we're going to take 5.2 and multiply it times 2 volts, and that gives us 10.4. We're going to do measure voltage RMS. So we have 10.4, and we're going to divide that by 2 and then multiply it times 0.707, and then that gives us 3.6764 volts, which is what we are running here. Read the period. So we're doing it old school. We're going to count the number of divisions, which is 1, 2, 3, 4, 5 for 1 full wave. So we're going to take 5 times 200, because that's the seconds, and then we're going to do it times 10 to the negative 6, and that gives us 1 over 1,000, which is our 1 millisecond. Okay, so now we're going to measure frequency, and frequency is just 1 over time. So we're going to do 1 divided by, and that gives us our frequency, which is also 1 times 10 to the EE negative 3. so now we're going to be doing measurements new school way. We're going to start with voltage peak to peak. So we're going to go to voltage and scroll down to voltage peak to peak. And that's going to give me 10.4 volts. Now I'm going to do the voltage RMS. So we scroll all the way down, we get VRMS, 3.58 volts. It's hovering back and forth, no big deal. Now we're going to measure the period, which is under time. 1 millisecond. And finally our frequency, which is 1 kilohertz.
So now we're going to take our measurements peak to peak for the oscilloscope. Old school. We count our blocks. We got 1, 2, 3, 4, let's say 8 or 9, 4.9. And then we take that and we times it by the 500 millivolts. So we got 8.9 times 500 e to the negative 3, which gives us 4.45 volts. So we're going to measure voltage peak to peak across resistor 2, which is on channel 2. Old school method, where you count the blocks. You got 1, 2, 3, 4.9. Then you times that by 500. I don't know what that is. By 500 millivolts. And use your 2.45. Alright, now we're going to do the RMS voltage, which is you take your voltage peak to peak, which is 2.45, and you divide that by 2, and then that gives us 1.225, and you times that by 0.707, it gives us our 0.866, which is right here. Next we're going to measure our period by counting our squares, old school method, across resistor 2, which is 1, 2, 3, 4, 5, times 200 microseconds, so it's 200 times 10 to the negative 6, which gives us 1 millisecond. And then to find the frequency, it's frequency equals 1 over time, so we have 1 divided by our answer, and it's 1,000 hertz, which is right here. Now we're going to measure new school method on the oscilloscope. First we're going to find our voltage peak to peak. It's right here, 2.46. Then we're going to find our voltage RMS. We have our 867 millivolts, which transfers to 867 volts. Now we're going to find our period, which is 1 millisecond, and then we're going to find our frequency, which is 1,000 kilohertz or 1,000 hertz, which is again shown here. Alright, now we're going to do the RMS voltage, which is you take your voltage peak to peak, which is 2.45, and you divide that by 2, and then that gives us 1.225, and you times that by 0.707, it gives us our 0.866, which is right here.